Hi, I'm RL from MathinSG.com. In this video here, I'll be going through the 2024 H2 A-Level Math Paper 1 Question 5. So this question here is an APGP question. So in the first part, we are given that a geometric series has a first term A and a common ratio R where R is lesser than 0. The sum to infinity of the series is 18 and its third term is 8 over 3. So there are two things we need to take note. Since R is lesser than 0 and sum to infinity exists, so we know that R is between -1 and 0, because in order for a GP to have sum to infinity, R must be in between -1 and 1, right? And at the same time, we are also given that R is lesser than 0. So combining these two, R is lesser than 0, sum to infinity exists. In other words, R is in between -1 and 1. We know that R is in between -1 and 0. Okay? So now, next, we know that the sum to infinity of the series is 18. So sum to infinity takes this formula, A over 1 minus R. So we know that sum to infinity, which is A equals to 1 minus R, is equals to 18, right? So we can form an equation, A equals to 18 minus 18R. Okay. Okay, next, third term is 8 over 3. So third term is AR squared. I know AR squared is equals to 8 over 3. That means A is equals to 8 over 3R squared, which is 2. Okay, so now I can solve. Oh, they didn't ask me to solve, so I can just equate 1 equals to 2, and I just need to show this one. So A is 18 minus 8R. It is also equals to 8 over 3R squared. Okay, so I will expand, but before that, let's first divide everything by 2. So I have 9 minus 9R equals to 4 over 3R squared. Then let's do a cross multiplication. So I have 27R squared minus 27R cubed equals to 4. Then I need to make it into this form, right? So I'll bring everything on this side over to here. So I have 27R cubed minus 27R squared plus 4 equals to 0. So I have shown. Okay. Next, they asked us to find the value of R and A. So first thing first, they didn't say cannot use the graphic calculator. So we'll use the GC, or just basically your scientific calculator, to solve for R cubed. Okay, and because we know that R is in between -1 and 0, we reject any values of R that do not lie within this region. Okay, so by GC, we know that R is equals to -1/3 or 2/3. Okay, since R is in between -1 and 0, we will reject R equals to 2/3. So therefore, R is equals to -1/3. Okay, then we will sub maybe R equals to -1/3 into either equation 1 or equation 2. So from 2, I'll use 2. So R is equals to 8 over 3 minus 1/3 square. Okay, type the whole thing into your calculator. You'll get 8 equals to 20. Sorry, A equals to 24, not R. A. Okay, so therefore we have found A and R already. R is -1/3. A is equals to 24. Next, we are given the nth term of the series UN. Okay, the nth term of a series is UN. It is given that this, so you find the value of K. So we know that 80, okay, then from so 80 times the sum of the K plus 1 term all the way to the infinitive term is equals to the first to the kth term, right? So what do we know from here? Well, we can rewrite this, right? So we can rewrite this one as 80 infinity R K plus 1 UR is equals to 80 R equals to 1 infinity UR minus 80 R equals to 1 K you are, right? So I'm going to replace this portion here with this one here. Okay, so I have 80 of this. Okay, now I can combine these together. So I have 80 sum to infinity is equals to 81, the sum of the first k terms. Okay. Okay, so we know that for this series here, okay, for this series here, the A is equals to 24 and the R equals to negative 1/3. What else do we know? Well, we also know that the sum of infinity, which is this one here, right? Sum to infinity is equals to 18. So let's sub in. I know this is sum to infinity and it is equals to 18. And I know this is the sum of the first k term. So sum of first k term in a GP is A 1 minus R. Maybe let me use more space. I need more space. So I have this, right? So I know this is sum to infinity. So this as infinity. And then this one here is the sum of the first k term, right? So I know that sum to infinity is basically just what is given here, 18. Next, I know that this is the sum of the first k term. So sum of first k term as sum of first k term is A 1 minus R to the power of k over 1 minus R, right? So I know A, I found it in part B, is 24. Then 1 minus negative 1/3 to the power of k over 1 minus minus 1/3. Okay, so based on this, I can simplify this first, or I can just simply type everything into the GC and solve it. Okay, so it's basically, this one is 4 over 3, right? So this 4 over 3. So I can actually take 80, 18, 81, 4 over 3 over 24 equals to 1 minus negative 1/3 to the power of k. Okay, then simplify everything here. So wait, no, sorry, 81 should be at the bottom. 81, yeah, okay. Okay, so basically I divide everything by 9, I get 2 over 9. Divide everything by 8, I get 3, 10. Then I have yeah, over 3, yeah. So if you have to simplify this whole thing, you'll notice that negative 1/3 to the power of k is equals to 1 over 81. Right, so 18. Okay, and from there you'll be able to solve for k, which is equals to 4. If you look at this, this is basically 1/3 to the power of 4, or negative 1/3 to the power of 4. So k is 4. So therefore we have solved for k, which is equals to 4. Okay, if you find this too complicated, basically just type everything into your GC, just equate it, use the graph to solve for k. Okay.